This is Big Mike, aka the Computer Dad, back with my buddy Studious Bear, and we are continuing the series on the Slate 7 Wi-Fi 7 travel router from GL-INET. During the unboxing video, we went through the UI fairly quickly. Today, the plan is to go through the following: reviewing the interface, various options that exist on the platform with its current firmware, change the subnet on the LAN scheme, and set up the SSIDs for wireless connectivity. And then my plan is to do a review of what that looks like from a client perspective. We'll use an iPhone as an example of connecting to that wireless network, what the process looks like with the QR code, and how it looks in the UI as far as what clients are connected to the travel router. We'll be able to see all of the IP information, everything that we've set up in this video on the client, and it will give us hopefully a perspective into what it takes to set this up from a basic level, just setting up those SSIDs and that network to be what we want it to be. In future videos, we plan to go through the VPN configuration, setting some of that up with the OpenVPN client, and getting a little bit deeper into some other tools and applications that exist on this platform and how that we can go about setting that up for secure remote access and even access back into our own network. In my case, a Ubiquiti UDM Pro from a remote network. And I'm excited for that one. So that's going to be part 3, but part 2 is going to be going under the UI, getting under the hood a little bit, and doing some basic configuration changes. Let's dive in. In the unboxing video, I'd gone very quickly through getting access to the UI and clicking around some of the settings. This will be a deeper dive into the UI, and it's just a refresher. The way I'm connected to this device is that my PC is connected wirelessly to the SSID, the wireless network of the travel router. This gives me the ability to get an IP address from DHCP on this device on the network of the travel router and be able to hit its gateway IP, which is this 192.168.8.1 address, log in with the admin password I created, and get into the management UI of the travel router. So we'll go through this very quickly. I'm not going to touch base on all the components, but mainly the ones that are most important for the basic configuration of this. But I'll highlight some things that may be worthwhile looking into, things that I'm not necessarily familiar with yet, but I'm going to get an education on. However, it will be focused on, here's how we set up the wireless networks, here's the options within the wireless networks, here are the settings for the LAN downstream, the local area network. So that subnet scheme, how we want to set that up and get that ready for clients to connect into. Let's get started. As we look at the UI, thing I want to focus on, and we went through this in a prior video, but just to reiterate, we have an Ethernet connection. So I have a Ethernet cable running back to a switch whose port is configured on my test bench network into the WAN 2.5 gigabit switch or gigabit port of the travel router. This provides network connectivity effectively. What it is doing is NAT, network address translation. So it is taking the private IP address from the wireless network downstream that my PC is connected to, natting it back to the private IP address scheme of my test bench network, and then natting it again out of my public IP address to my internet provider. That is what is providing me network connectivity on this travel router, but the ability to segment a separate wireless network downstream from my test bench network. So what we're doing is we have that wirelessly connected, but there are other options. We can tether or repeat from an existing wireless network. We can also use a tethering service so we can connect a cellular device to this platform via USB-A cable on the back and allow it to use the LTE service of the cell phone as a WAN source. So those are various options that you can choose. I'm, for the case of this lab, setting it up with an Ethernet connection. This would mimic if I am out at a hotel, for example, and that hotel had an available Ethernet port that I could connect into, and assuming that that port doesn't have any type of port security for specific devices the hotel is using, it would allow me to pick up DHCP from that network and start to build that private network downstream using the hotel's network for that purpose. So here we're using that network. My test bench network is the 192.168.30 subnet scheme, and it's getting DHCP from that. But I'd like to go through the various wireless settings, some of the different menus, call out things that I'm not terribly familiar with, but things that I will be setting up in later videos of working through this Slate 7 router setup. Because again, I do have a trip coming up that I'd like to have this prepared for. So as part of that, I'm building this for that purpose. As we go into wireless, we can see MLO, which stands for multi-link operations. That's unique to Wi-Fi 7. It's a feature that allows any clients to connect over multiple bands. In our case, in the case of this Slate 7, it only supports the two bands that are most traditionally known, 2.4 gigahertz and 5 gigahertz. With a lot of Wi-Fi 7 devices and advanced access points, you're seeing the 6 gigahertz band added as well. In this case, it is only a dual band device, so we are able to have clients connect across both of those if that is enabled and is the only connected, or a device is connected to that MLO Wi-Fi network. We have the settings for the traditional 5 gigahertz and 2.4 gigahertz network as well, and those are enabled. We can modify those here. So if I wanted to go in and make changes to that, for example, I wanted to change the Wi-Fi name, I wanted to change the Wi-Fi password or pre-shared key, PSK, if I wanted to make that hidden, if I want to set the Wi-Fi mode in terms of what maturity level or generation of Wi-Fi that is using, I can set channel and bandwidth. All of those things can be set. I can also set additional WPA security options for how that's going to be used. So those are options within the Wi-Fi that I can configure and manage. I can also just turn it off if I wanted to just use the MLO Wi-Fi and not the 5 or 2.4 gigahertz. The other option is I can set up a guest Wi-Fi network. So I can enable this and have guest Wi-Fi available in that same token. So that I don't see anything right now that allows me to limit. For example, with my Ubiquity system, I have the ability to create a separate network, and then on that SSID, I can set throughput limits or bandwidth limits. I could set profiles on that so that anybody that's connecting to it can only get 10 meg, for example. They can't take up all my bandwidth with streaming or gaming or anything they may be doing on my network. I don't see those controls here. They may be. I have to dig a little bit deeper, but just calling that out is something to consider. Whenever you set up a guest network, typically you want some throttling involved so that they can't chew up the entire available bandwidth doing whatever it is that guests do on the network. Going down the list, we can see the clients and the client lists. This is the PC that I'm currently connected to, all the information about that, and the ability to turn on a reserved IP. So if I apply this, now I have the ability to reserve this IP, which, as we see here, when you hover over it, it reserves that as a DHCP reservation. So there's two ways you can typically assign an IP address that stays with a device. You can do a static assignment, which means that that IP address that is assigned to a device exists outside of the DHCP, the dynamic range of IPs that's being handed out by your router. Or you can use a DHCP reservation. That takes the MAC address of that device and associates it to the IP address so that anytime that lease renews, it gives that IP address back to that device with that MAC address. So it sets that reservation so it is the same IP. There's schools of thought on whether or not static versus DHCP reservations are better. To each their own. I prefer the DHCP reservation method. I think it's a little bit cleaner, and you have a list of everything that's statically assigned inside your DHCP scope and your DHCP server. So it's cleaner to audit instead of having to guess what is assigned to what outside of your DHCP scope. Just my opinion, for what it's worth. Cloud services. I don't know what either of those are, so I'm not going to dive into them. VPN. The one I will focus on is the OpenVPN client, which is what I'm going to set up in a third video using Cloudflare Dynamic DNS and my Ubiquity Dream Machine Pro, the OpenVPN server on that platform. And I want to give a shout out to my buddy Glenn from LinkedIn, fellow engineer. He had called out the interest of using that on his home UDM Pro, and I'm like, oh, now I got to do that. So thank you, Glenn. You gave me the motivation to put that into a video and get that all set up. So I'm looking forward to that in the next video here as we get VPN services set up. Looking at applications, there's a variety of options in here, all of which I'm not going to dive deep into. They have its own dynamic DNS. Network storage I thought was interesting, where you could, I believe, I haven't tested it yet, but I believe you can connect a storage device to this travel router and then set up network-based shares with various permissions in here. And as you look at it, you can see the file services, shared folder, user management, all of those more mature options available within the platform to create those shares, which I mean, that's just pretty cool. So if you have media shares or something like that, whatever you can think of you want to share, you have the ability to do that over this travel router using the wireless network. So we look at the network. This is where we start to get into those configuration settings that matter in terms of the LAN and subnet configuration. and also some of the other more mature features that are available on this travel router. We won't go into port forwarding here because we're not going to be using that in this case, but I do want to call out multi-WAN. I have the ability to create a multi-WAN scenario and do failover or load balancing. I thought that was incredible. I don't believe that, maybe it was a setting in the other UI, I don't recall that, but that is a great setting to have here. So if I have a hardwire like I do now, and I can tether it to my LTE service with a phone hotspot, now I can set it up and I can test that, and I plan to, where I unplug the Ethernet cable and it automatically fails the WAN over, and I can see, maybe ping drops or it reconnect, and then I can check and an IP chicken outbound, see what my public IP looks like, all of those things to verify that it's working successfully and that it has in fact failed over. And also failback is another thing you want to test. So when that service comes back up, does it fail back to the original primary based on your interface priority listed here? So the next thing we're going to go into is the LAN configuration. So we're going to take some time to talk about how we want to build the LAN configuration, and then go back to the Wi-Fi settings, connect a client, and test it all out. Let's get to it. All right, I want to pull up just a quick overview of how I'm approaching the LAN scheme design. You could absolutely leave this alone. Out of the box, it's 192.168.8.0/24. It is not at all conflicting with my test bench network, which is the 192.168.30. You have to be considerate of that, especially if there's a conflicting LAN scheme. So if you're going to a place like a hotel, you'll have to see what the IP scheme is and determine if you need to make a change on your travel router, just to avoid any potential routing issues with that double NAT sequence as it's getting out of your source network, your WAN network, if you will. In this case, I just wanted to throw up a reference, and this might be important for folks that are studying for their CCNA or their Net Plus, or just looking for a refresher on subnetting. The RFC 1918 that defines, and RFC stands for request for comment, the article or document that outlines Class A, Class B, and Class C subnetworks, private IP networks that could be used for an internal network scheme. So typically what you want to look at is, what is your WAN scheme on these things, because you're going to be borrowing, if you will, a network that may already exist. It's not typical that you're going to connect this travel router to an ISP directly that's in bridge mode that passes the public IP directly to the WAN port. It's not likely that that's going to happen. You're going to be borrowing another LAN from another location to allow yourself to get out into the internet using that network. So with that, you'll have to figure out, what do you want to use for your subnet scheme? So if you get into this, the default again is fine. I'm choosing to use 10.10.0.0/24 and going into configuring what that looks like and making modifications to the LAN scheme on the travel router. So just keep that in mind and do a little bit of reading. Understand, if you don't have a firm grasp on the subnetting concept, just keep that in mind as you configure a LAN design, because that's going to be important for the deployment or changes that you may make to this travel router. And we'll get into that in a moment. All right, now we're going to configure the new LAN scheme on this travel router. The thing that I want to call out is, keep in mind, you will get disconnected. We will no longer be using the 192.168.8.1 network, so we will have to request a new lease from the Wi-Fi network once that is changed, because it is going to modify the DHCP server settings. We're changing the router IP address, so it's no longer 192.168.8.1 as I said. The net mask is going to stay the same. That's a /24 network, so we get 254 usables. And then we are going to modify the start IP address and the end IP address of that DHCP server. So we'll go ahead and do that now. So we'll set this up for 10.10.0.1. We'll keep that .1 scheme as our gateway. And then we're going to set this up as 10.10.0.100. And we'll do 10.10.0.200. And we'll set up advanced. We can see our lease time. We can define DNS server if we want to. We're going to leave that all default. I'm not worried about that. And it's probably going to yell, or I suspect it may be in red, because these settings have to be applied first. See, it doesn't seem to want to take that configuration. So let's test it live. We're going to click this and we'll see what happens. So I'll apply this. It's going to say, please wait. Let me go ahead and pull up a command prompt. I'm going to ping. I got nothing. And look at that. It already flipped it right over for me. So I didn't have to do anything there, which is outstanding. So it already flipped it over to the 10.10.01, which is excellent. Now I know that this is applied here, and then this reservation will no longer matter. So I can turn that off. It looks like it dropped it right on 226, which totally fine, but I don't need to have that reservation anymore. But it flipped it right over and reconnected to me. In some cases with other devices that I've set up, it breaks that connection. You have to effectively request a lease from the DHCP server and then go back to the gateway, log back in. This has intelligence enough to flip me over automatically to that new network and keep me logged in to that session so I don't lose connectivity. I've definitely done this a time or two where I've had that chill go down my spine where I'm like, oh, I got disconnected. Oh, I don't know if I remember that password. Always make sure you document your passwords. Always make sure you're testing connectivity. Always make sure you're aware of what's going to happen downstream, especially in production networks. Let's say I was doing this live and I had 15, 20 clients. I need to know that there's going to be obviously an outage as a result of me disconnecting and changing that LAN scheme. There's going to be a change to those clients downstream. Now, with this particular device, it was relatively quick, so I would hope for downstream with those devices they would get the new lease and be able to continue working. And obviously, I'll test that as we go through the experience with this travel router, but something nonetheless to keep in mind. So we've set that LAN scheme up. Next, we're going to focus on the SSIDs, creating a unique SSID, a unique PSK, and getting a client connected to that wireless network and seeing what that experience looks like. All right, we are going to set up the SSID. We're going to set up the MLO Wi-Fi. Again, that's that dual band or multi-band connectivity. In this case, we have a dual band wireless router, but it allows for clients to connect across 2.4, 5, and if you have tri-band 6 gigahertz networks. We are also going to use WPA3 SAE, which stands for Simultaneous Authentication of Equals. I am not a Wi-Fi expert or Wi-Fi engineer per se, but I know that this is the next generation of what has been traditionally the WPA2 with PSK or pre-shared key configuration. This is a more secure method of wireless authentication using a password or passphrase for the wireless clients to use to connect into that wireless network. So in this case, we're just going to name it, we'll keep it simple. So we'll call it TCD Wi-Fi, and we'll change that. We'll just make something silly for the PSK, make sure that that's shown. We'll go ahead and apply it. And then we'll make sure we'll switch to our secondary screen. Get rid of the screenception. And then we'll just check to see if that pops up. TCD Wi-Fi, there we go. And we are connected and secured. All right. We'll switch that screen back. We'll go ahead and take a look at our clients. We can see here what Wi-Fi we are connected to. And we should have the same IP scheme because regardless of SSID, it's using the same LAN. So we'll check that again just to make sure nothing's changed there, which I don't anticipate it has. So there we go. Connection specific DNS suffix, which we don't have defined. We can see that I am connected to that wireless network and 10.10.0.226, which we saw in the client list. So that is effectively it as far as setting up the Wi-Fi in such a way that, for example, I could now turn off these other two networks, and I would no longer see them in my available list for the wireless. It wouldn't affect it in any way. But again, this device would determine what channel it's going to communicate across, or what network, what band it's going to communicate across, and work that way. This is, and I also have the QR code, which I'm going to test from the perspective of a mobile client and record that and put that in the video as well, what that looks like. But this is basically it. I mean, from a get it out of the box, get it connected to a network, configure, making sure you don't have a conflicting subnet scheme from your WAN to LAN, and then setting up an SSID that you choose. This is really how simple it is to get this up and working. A lot of people that are, maybe not even that tech savvy could probably get this thing off of the ground pretty quickly, save for obviously the subnet theory. They're not going to go read the RFC 1918, but it gives them the ability to set that up, and by default they could just keep the scheme out of the box and be ready to go. So we're going to look at connecting it to a cellular device and using that for Wi-Fi with the QR code, what that experience looks like. I'm also going to show you a preview of what it looks like from the touch screen of this device and just some feature functionality from the actual unit itself. And then we're going to go into configuring some of the cool features with the OpenVPN client and doing a bunch of stuff for dynamic DNS and recording all of that fun so we can put it all together in a, hey, this is out of the box. You set it up for WAN connectivity. You configured your SSID. You configured your LAN scheme. You configured secure connectivity with a VPN client. You are ready to take this show on the road and connect clients to it in a secure way that you control and you dictate, which is really, really cool, especially if you travel all over the place and you don't want to have to reconnect clients to a new Wi-Fi every time you visit a new location. You set this thing up, everything downstream automatically connects to your wireless network on your travel router. You don't have to constantly reconfigure everything. Talking kids' iPads, talking gaming systems, talking anything smart in the environment that you're setting up automatically connects to the network that you're setting up on this travel router, which is what we want. To wrap this video up, we're going to go ahead and get a cell phone connected using the QR code, and then I'll talk over a video I took of navigating the touch screen on the front of this device. That should wrap us up nicely for this video as we look ahead to setting up the VPN and getting the final video of this 3-video series for the travel router all set up. We are scanning the QR code that's displayed on the UI when you're hovering over the SSID in the travel router web interface, and we can see here that it connects right away. Easy peasy. Same Wi-Fi password, the PSK that we set, same subnet that we're expecting. The touchscreen menu is really where this unit stands out. The older model didn't have this. We have the ability to swipe to different menus and turn on and off different Wi-Fi SSIDs if we have several configured, turning on the MLO or the 5 or 2.4 gigahertz. We can also see if the clients are connected. Any of the other features we can turn on or off in this session. So it really makes it a unique experience from a usability perspective. And that's something that wasn't available in the prior models. So this is really cool to see in here. And it's really why I love this model and I wanted an excuse to get it. So hopefully this video was helpful for you if you're interested in getting something like a travel router. This will help you get off the ground with setting it up. If you have any questions, feel free to leave them in the comments or let me know. Reach out to me directly. Happy to answer them. I'm still getting under the hood of this thing, still trying to learn all the little nuances of the unit, and I am excited to share those as I figure those out. So please stay tuned for the next video, which is going to be focused on VPN, and I look forward to any questions you may have. Thanks for watching.